Ladies and gentlemen, for decades, we've watched movies and read books that imagined a future filled with flying cars. A world where traffic jams are a thing of the past and people can soar above cities in their personal vehicles. What once seemed like a distant dream is now becoming reality. Flying cars are here. The idea of flying cars is not new. Inventors and engineers have been working on them for over a century, but only recently has technology caught up with ambition. Thanks to advancements in electric propulsion, artificial intelligence, and aerospace engineering, we are witnessing the birth of a new era in transportation. So, how do these futuristic machines work? Most flying cars today are designed as VTOL, vertical takeoff and landing, vehicles, meaning they don't need a runway. Some function like drones, using multiple rotors to lift off, while others resemble small airplanes with foldable wings. These technologies are paving the way for a revolution in mobility. For generations, humanity has been fascinated by the idea of flying cars. From classic science fiction novels to blockbuster Hollywood movies, the vision of a world where vehicles soar through the skies has captured our imagination. We've all seen it, whether it was in the Jetsons, Back to the Future, or Blade Runner. The dream of a futuristic city filled with flying cars has always seemed like a distant fantasy. But today, that fantasy is turning into reality. Throughout history, science fiction has often been a glimpse into what the future could hold. There was a time when people thought traveling to the moon was impossible, yet in 1969 we did it. There was a time when the idea of talking to someone across the world through a handheld device seemed like magic, but today, smartphones are an everyday part of our lives. And now, we are witnessing another major technological leap, the birth of real, working flying cars. One of the first serious attempts at a flying car dates back to the 1920s. In 1926, aviation pioneer Henry Ford introduced the Ford Flivver, a small aircraft designed for personal use. While it never became a commercial success, Ford boldly predicted that a flying car was inevitable, saying, "Mark my words, a combination of airplane and motor car is coming. You may smile, but it will come." His prediction was not wrong, it just took longer than expected. Over the years, many inventors and engineers continued to chase the dream. In 1946, the Convair Model 118 was developed, a car with a detachable airplane engine and wings. In the 1950s, the Aero car was introduced, one of the few flying cars that actually received approval from aviation authorities. However, despite these creative designs, none of them made it into mass production due to limitations in technology, safety concerns, and high costs. The real breakthrough came in the 21st century when advancements in materials, electric propulsion, and artificial intelligence reignited the push for flying cars. Unlike the bulky and impractical designs of the past, modern flying cars are sleek, efficient, and capable of VTOL, vertical takeoff and landing, meaning they can lift off and land without needing a runway. This has opened up new possibilities, making flying cars more practical than ever before. In recent years, several companies have taken major steps toward turning this dream into reality. Aleph Aeronautics has developed a fully functional electric flying car that can drive on roads and take off vertically. Klein Vision's air car completed a successful intercity flight, proving that a hybrid car airplane is not just possible but already here. Joby Aviation and Archer Aviation are developing air taxis that could soon become a part of daily urban transportation. Even major automakers like Hyundai and Toyota have invested billions into flying car research, recognizing that this is the next big leap in mobility. Governments and aviation authorities are also beginning to take flying cars seriously. The U.S. Federal Aviation Administration, FAA, has started approving test flights, and cities around the world are preparing for the integration of aerial vehicles into transportation systems. Countries like Dubai and China are already testing air taxi services, signaling that we are closer than ever to a world where flying cars are a common sight. The rise of flying cars is no longer a question of if, but when. What was once a futuristic fantasy is now an emerging industry, and as technology continues to evolve, the way we think about transportation is about to change forever. The concept of a flying car may sound like magic, but behind the scenes, it is a combination of cutting-edge engineering, aerodynamics, and modern propulsion systems. Unlike traditional airplanes, which require long runways for takeoff and landing, most flying cars today rely on VTOL, vertical takeoff and landing, technology, allowing them to lift off like a helicopter and transition into forward flight like an airplane. This breakthrough makes flying cars practical for urban environments, where space for traditional runways is limited. VTOL, the key to flying cars. VTOL technology is what separates modern flying cars from earlier designs. Instead of requiring an airport or a long stretch of road, VTOL vehicles can take off and land almost anywhere, including rooftops, driveways, and small landing pads. There are two main types of VTOL flying cars. Multirotor-based flying cars. These resemble oversized drones, using multiple electric rotors to generate lift and propulsion. Companies like Joby Aviation, Volocopter, and EHang have developed electric VTOL, eVTOL, vehicles that operate quietly, efficiently, and with zero emissions. These vehicles rely on battery-powered motors, making them more environmentally friendly than traditional helicopters. Fixed-wing VTOL flying cars. These vehicles combine elements of an airplane and a car. They have wings for efficient forward flight, but also include rotors or tilting propellers for vertical takeoff. The Klein Vision Aircar and Aleph Aeronautics Model A are examples of this hybrid approach, where a car can drive on the road and extend wings when it's ready to fly. Electric and hybrid propulsion. Most modern flying cars are powered by electric or hybrid electric propulsion systems. Traditional combustion engines, like those found in airplanes, are loud, expensive to maintain, and produce carbon emissions. To address these issues, many companies are focusing on electric flying cars, which offer several advantages. Quiet operation. Unlike helicopters, which generate significant noise pollution, electric flying cars produce minimal sound, making them more suitable for city environments. Eco-friendly. Since electric flying cars don't rely on fossil fuels, they contribute less to air pollution and climate change. Lower maintenance costs. Electric motors have fewer moving parts than internal combustion engines, reducing wear and tear and making maintenance more affordable. However, one of the biggest challenges facing electric flying cars is battery technology. For now, batteries are still heavier and less energy-dense than aviation fuel, limiting flight time and range. While most current models can fly for 30 to 60 minutes, researchers are working on next-generation batteries that will allow for longer distances and higher efficiency. Autonomous and AI-assisted flight. Flying a vehicle in the sky is much more complex than driving on the road. That's why many flying car manufacturers are incorporating artificial intelligence, AI, and automation to assist with navigation, safety, and air traffic management. Some of the key advancements in this area include autonomous flight. Many flying cars are being designed to operate with minimal pilot input. AI-powered autopilot systems can handle takeoff, navigation, and landing, reducing the need for highly trained pilots. Collision avoidance. Advanced sensors, cameras, and radar systems help flying cars detect and avoid obstacles, including buildings, power lines, and other aircraft. Smart air traffic control. With more flying cars in the skies, cities will need urban air traffic control systems to prevent accidents. AI-powered networks will manage flight paths, ensuring safe and efficient air travel. Materials and aerodynamics. The materials used in flying cars are also crucial to their success. Unlike traditional cars, which use heavy steel frames, flying cars need to be lightweight yet strong to achieve efficient flight. Modern flying cars use carbon fiber composites, aluminum alloys, and advanced polymers, reducing weight while maintaining durability. Aerodynamics also plays a critical role. A well-designed flying car must balance both road efficiency and air efficiency. Some models, like the Klein Vision Aircar, have retractable wings that extend for flight and fold away for driving, ensuring a smooth transition between the two modes. Others, like the Aleph Aeronautics Model A, have a unique body design that doubles as a lifting surface, allowing for stable and controlled flight. The future of flying car technology. As technology continues to advance, we can expect further improvements in flying car performance, safety, and affordability. Next-generation batteries, hydrogen fuel cells, and lighter materials will allow for longer flights and greater efficiency. AI will continue to improve autonomous capabilities, making flying cars accessible to a wider audience, even those without a pilot's license. While challenges remain, the foundations have been laid for a future where flying cars become a regular part of urban and inner-city transportation. With each passing year, the technology is improving, bringing us closer to a world where the skies are filled with personal air vehicles, revolutionizing the way we travel. The arrival of flying cars represents more than just an exciting technological advancement. It has the potential to completely transform how we travel, work, and live. For decades, transportation has been limited by roads, highways, and traffic congestion. Flying cars offer an alternative that could revolutionize urban mobility, making travel faster, more efficient, and more accessible to millions of people worldwide. 1. Faster travel and reduced commute times. One of the most obvious and immediate benefits of flying cars is speed. Today, millions of people spend hours stuck in traffic every day, whether it's in major cities like New York, Los Angeles, or London. With flying cars, those frustrating delays could become a thing of the past. Imagine cutting a 60-minute car ride down to just 10 to 15 minutes by flying over traffic instead of being stuck in it. Flying cars, especially VTOL, vertical takeoff and landing vehicles, can take off directly from parking lots, rooftops, or driveways, avoiding congested streets altogether. This not only saves time but also improves productivity by giving people more hours in their day for work, leisure, or family. For businesses, this means quicker deliveries, faster emergency response times, and improved logistics. Instead of waiting hours for an important package, a flying delivery vehicle could transport it in minutes. Medical professionals could reach patients faster, and first responders could navigate disaster zones with ease. 2. Reduced traffic congestion. One of the biggest problems in modern cities is traffic congestion. Roads are overcrowded, accidents cause major delays, and the increasing number of cars on the road only makes things worse. Traditional solutions such as building more highways, expanding public transportation, or implementing toll systems have had limited success in solving the problem. Flying cars introduce a completely new dimension of travel, the sky. By shifting a portion of urban transportation from roads to the air, cities can significantly reduce traffic congestion. Instead of millions of cars crowding highways, a well-regulated air mobility system could allow thousands of flying cars to operate simultaneously in urban air corridors, easing the burden on ground transportation. Additionally, fewer cars on the road mean less wear and tear on infrastructure, reducing the need for constant road repairs and maintenance. Governments could allocate funds to other critical areas instead of continuously expanding highways and fixing damaged roads. 3. Environmental benefits and sustainability. While traditional aircraft and helicopters rely on fossil fuels and produce significant carbon emissions, many flying cars are designed to be fully electric. This shift toward electric flying vehicles has major environmental benefits, including lower carbon emissions. Since many flying cars are powered by electricity, they produce zero direct emissions, reducing air pollution and contributing to cleaner cities. Energy efficiency. Electric flying cars are designed to be more energy efficient than conventional aircraft, using cutting-edge battery technology to maximize performance while minimizing environmental impact. Less urban pollution. Reduced congestion on roads means fewer idling vehicles emitting harmful gases, leading to improved air quality and better public health. Although battery technology still has some challenges to overcome, such as range limitations, continuous advancements in energy storage solutions, such as solid-state batteries and hydrogen fuel cells, will make flying cars even more sustainable in the near future. 4. Improved accessibility and inclusivity. Flying cars have the potential to improve accessibility for people living in remote or underserved areas. Today, many rural communities suffer from poor transportation infrastructure, making it difficult to access essential services like healthcare, education, and employment. Flying cars could bridge the gap between these areas and urban centers, offering faster and more reliable transportation options. For example, a doctor in a remote village could use a flying car to reach a hospital in minutes instead of hours. Students in isolated areas could commute to schools and universities more easily. Businesses could deliver goods to hard-to-reach locations, boosting economic opportunities in rural regions. Additionally, air taxis and ride-sharing services could make flying car travel available to a broader audience, not just the wealthy. Just as ride-sharing services like Uber and Lyft revolutionized transportation by making it more accessible and affordable, flying car services could offer on-demand urban air travel, making it an option for everyday commuters. 5. Emergency and disaster response. Another major benefit of flying cars is their ability to assist in emergency situations and disaster response. During natural disasters like earthquakes, floods, or wildfires, traditional rescue efforts can be delayed due to blocked roads and inaccessible areas. Flying cars, with their ability to take off and land in compact spaces, could provide faster emergency response, delivering aid and rescuing people trapped in dangerous conditions. For example, ambulance drones and medical air taxis could transport critically ill patients to hospitals much faster than ground ambulances. Firefighters and rescue teams could use flying vehicles to reach areas where roads are destroyed or blocked. Law enforcement could deploy flying cars for rapid response in crime or emergency situations, ensuring public safety. 6. Economic growth and job creation. The flying car industry is expected to create millions of new jobs in the coming decades. As more companies invest in urban air mobility (UEM), there will be growing demand for engineers and designers to develop better flying car models, pilots and air traffic controllers to manage urban air traffic, maintenance and service technicians to ensure vehicle safety and performance, software developers and AI specialists to improve automation and navigation systems. Furthermore, cities that embrace flying car technology early could attract investments, boost tourism, and position themselves as global leaders in futuristic transportation. 7. Potential cost savings for governments and individuals. Although flying cars may seem like a luxury at first, they could actually lead to long-term cost savings for both governments and individuals. Cities spend billions of dollars each year on road maintenance, highway expansions, and public transit subsidies. By shifting part of the transportation burden to urban air mobility, governments could reduce infrastructure costs and allocate resources more efficiently. For individuals, flying cars could reduce time wasted in traffic, lower fuel costs for electric models, and provide more direct routes, eliminating unnecessary detours and long commutes. While initial prices for flying cars may be high, just as with electric cars, prices are expected to decrease as production scales up and technology improves. While the idea of flying cars is exciting and full of promise, there are still major challenges that must be addressed before they can become a common part of everyday life. From air traffic control to regulatory approval, safety concerns, and cost barriers, the road to integrating flying cars into mainstream transportation is filled with obstacles. Despite recent breakthroughs, these challenges must be carefully navigated to ensure that flying cars are safe, reliable, and accessible to the general public. 1. Air traffic control and airspace management. One of the biggest concerns with flying cars is how to manage air traffic in urban areas. Unlike traditional airplanes, which operate in designated airspace and follow strict flight paths, flying cars will need to share the skies above busy cities where thousands of vehicles will be taking off, landing, and traveling in different directions. Currently, the Federal Aviation Administration, FAA, and other aviation authorities tightly regulate air travel, ensuring that commercial and private planes follow structured flight paths to avoid collisions. But with flying cars, the number of airborne vehicles will increase dramatically, making airspace management far more complex. To solve this, governments and private companies are working on urban air traffic management, UATM, systems powered by artificial intelligence. These systems will act like a digital air traffic controller, ensuring that flying cars communicate with each other, avoid mid-air collisions, and follow pre-approved air routes. However, developing and implementing these systems on a large scale will take years of testing and refinement. Another issue is low-altitude flight zones. Drones, helicopters, and emergency response aircraft already operate in city airspace. Integrating flying cars without interfering with critical services, such as police helicopters or medical evacuation flights, will require careful planning and strict regulations. 2. government regulations, and legal approvals. For flying cars to become mainstream, governments must create new laws and regulations to ensure they are safe, reliable, and properly managed. Right now, most countries do not have clear guidelines for personal aerial vehicles, meaning companies developing flying cars must work closely with aviation authorities to obtain special permits and safety certifications. Some of the key regulatory challenges include pilot licensing and training. Will flying cars require a pilot's license? Or will they be fully autonomous? Most aviation authorities require rigorous training for pilots, but if flying cars are meant for everyday consumers, companies must develop easy-to-use systems that allow people to operate them safely with minimal training. Flight zones and no-fly areas. Governments will need to define where flying cars can operate. Will they be allowed over residential areas? Will they be restricted from flying near airports or government buildings? Strict no-fly zones will be necessary to protect privacy and national security. Crash liability and insurance. In the event of an accident, who will be held responsible? Will it be the manufacturer, the pilot, or the software controlling the vehicle? Aviation insurance laws will need to adapt to cover aerial vehicles for commercial and personal use. Noise and environmental regulations. Even though many flying cars are electric, they still produce some noise when taking off and landing. Governments will need to decide if noise restrictions should apply to flying vehicles in residential areas. Right now, companies like Aleph Aeronautics, Klein Vision, and Joby Aviation are working with regulators to obtain certification for their flying vehicles, but widespread government approval is still years away. 3. Safety concerns and risk of accidents. Safety is one of the most critical concerns for flying cars. While car accidents on the ground are already dangerous, an accident in the air could be catastrophic, leading to crashes in populated areas, fires, or property damage. Some key safety challenges include mid-air collisions. With thousands of flying cars expected in urban skies, ensuring they don't crash into each other will require advanced collision avoidance technology. These vehicles must be equipped with sensors, AI-driven navigation, and air traffic coordination systems to prevent accidents. Engine or battery failure. If a flying car's propulsion system fails mid-air, how will it land safely? Engineers are working on parachute systems, emergency landing protocols, and backup power supplies, but these must be tested rigorously before flying cars become widely available. Weather conditions. Unlike regular cars, which can operate in rain or fog, flying cars depend on clear visibility and stable weather. How will they handle high winds, storms, or extreme weather events? Autonomous flying cars will need sophisticated weather prediction technology to prevent dangerous flights. Cybersecurity risks. Since many flying cars will rely on software and AI automation, there is a risk of hacking and cyber attacks. If someone gains control of a flying car remotely, it could become a security threat. Companies must invest heavily in cybersecurity protections to prevent unauthorized access. While current flying car prototypes have passed early safety tests, widespread deployment will require years of additional research, testing, and regulatory approval to ensure they are as safe as traditional air travel. 4. High costs and limited accessibility. At the moment, one of the biggest barriers to flying cars is cost. The first generation of flying vehicles is extremely expensive, with some models priced at $300,000 to over $1 million. This makes them unaffordable for the average consumer. Some reasons for the high cost include expensive materials. Many flying cars use carbon fiber, titanium, and advanced composites, which are lightweight but costly. Battery and propulsion costs. High-performance electric motors and powerful lithium-ion batteries are still expensive to produce. Limited mass production. Since flying cars are new technology, mass production hasn't begun yet, keeping prices high. However, as with electric cars, costs are expected to decrease over time as technology improves. More companies enter the market. Mass production begins. Companies like Joby Aviation and Archer Aviation are working on flying car ride-sharing services, similar to Uber, which could make flying transportation more affordable for regular commuters. Instead of buying a personal flying car, people could pay per ride, significantly reducing costs. 5. Public acceptance and social challenges. Even if all technical and regulatory challenges are solved, another major obstacle is public acceptance. People may be hesitant to trust flying cars due to fear of flying accidents. Many people already have a fear of flying, and the idea of everyday people piloting flying cars may create safety concerns. Concerns about noise pollution. Even with electric engines, flying cars produce noise during takeoff and landing, which could lead to complaints in residential areas. Privacy issues. If flying cars can hover over homes, will they create privacy concerns for individuals on the ground? The road ahead. Despite these challenges, companies, governments, and engineers are actively working to solve them. Overcoming these limitations will take years of research, policy development, and infrastructure changes, but progress is happening fast. The transition from concept to reality will not be instant, but just like cars, airplanes, and smartphones, what seems futuristic today could soon become an everyday necessity. The widespread adoption of flying cars will require significant changes to urban infrastructure. Unlike traditional road vehicles, which rely on highways, streets, and parking lots, flying cars need specialized takeoff and landing zones, new air traffic management systems, and updated regulations to ensure they can operate safely in urban environments. For cities to fully embrace flying car technology, they will need to redesign transportation networks, integrate advanced communication systems, and create policies that support aerial mobility. While this transformation will take time, governments, urban planners, and private companies are already exploring solutions to prepare for this new era of transportation. 1. The rise of skyports, takeoff and landing zones. One of the biggest challenges of flying car infrastructure is the need for dedicated landing and takeoff zones. Unlike traditional cars, which can drive on roads and park anywhere, flying cars require vertiports, vertical takeoff and landing hubs, to operate efficiently. These skyports will function similarly to helicopter pads, but on a much larger scale. They will be strategically placed across cities, allowing flying cars to land, recharge, and pick up passengers. Some key features of these skyports will include multiple landing pads for simultaneous takeoffs and landings, charging stations for electric flying vehicles, passenger terminals for boarding and exiting, automated traffic management systems to direct air traffic. Major cities like Los Angeles, Dubai, and Singapore are already investing in vertiport designs, with companies like Uber Elevate and Lilium leading the development of urban air mobility networks. In the future, shopping malls, office buildings, and residential complexes may include rooftop skyports, allowing residents to fly directly from their homes to their destinations. 2. Smart traffic management systems, preventing aerial congestion. Just as cities have traffic lights, highways, and GPS systems for road vehicles, they will need advanced traffic management systems for flying cars. Without proper coordination, an increase in flying vehicles could lead to mid-air congestion, accidents, and flight delays. To solve this, urban planners and tech companies are working on AI-powered air traffic control systems that will monitor and regulate flying cars in real time. These systems will assign flight corridors, similar to highways in the sky. Designated air lanes will separate different types of aerial traffic. Prevent mid-air collisions. AI algorithms will track flying vehicles and adjust flight paths automatically to avoid accidents. Communicate with ground infrastructure. Traffic lights, emergency signals, and weather updates will be synchronized with flying car networks. These smart traffic systems will likely be operated by a mix of government agencies, private companies, and autonomous AI platforms to ensure a seamless experience. 3. Integrating flying cars with existing transportation networks. Flying cars won't replace traditional transportation overnight. Instead, they will be integrated into existing networks like buses, trains, and highways. Cities will need to redesign public transit hubs to accommodate both ground and aerial travel. For example, airports may expand their terminals to include flying car services, allowing passengers to travel from airports to city centers in minutes. Train stations could build vertiports on their rooftops, offering high-speed aerial connections between cities. Ride-sharing apps like Uber and Lyft may introduce flying car options, allowing users to book aerial rides just like they do with regular cars. This seamless integration will ensure that flying cars enhance existing infrastructure rather than disrupt it. 4. Power supply and charging stations for electric flying cars. Since most modern flying cars are electric-powered, cities will need to invest in high-capacity charging stations to keep them operational. Unlike gas stations for regular cars, these charging hubs will require fast-charging technology to minimize downtime between flights. Key infrastructure upgrades will include high-speed charging pads at vertiports and landing zones, wireless charging systems to allow flying cars to recharge mid-flight, battery swapping stations for quick energy replacement. Energy providers will also need to increase power grid capacity to handle the additional electricity demand. Some experts suggest integrating solar panels and renewable energy sources into flying car networks to ensure sustainability. 5. Noise reduction and zoning regulations. Even though electric flying cars produce less noise than helicopters, they still generate sound pollution during takeoff and landing. To prevent excessive noise in residential areas, cities may introduce special zoning laws that regulate where and when flying cars can operate. Possible solutions include designating flight zones. Certain areas may be restricted for aerial travel to prevent disturbances in quiet neighborhoods. Mandating noise reduction technology. Manufacturers may be required to use silent rotor designs and noise-canceling technology to reduce sound levels. Setting flight time restrictions. Similar to commercial airports, flying cars may be prohibited from operating during late-night hours in residential zones. By implementing these regulations, cities can ensure that flying cars improve mobility without disrupting daily life. 6. Safety and emergency infrastructure. To ensure the safe adoption of flying cars, cities will need to upgrade their emergency response infrastructure. This includes emergency landing zones, designated areas where flying cars can land safely in case of engine failure. Aerial rescue teams, specialized first responders trained to handle flying vehicle accidents. Automated crash detection systems, AI-powered software that can detect malfunctions and initiate emergency protocols automatically. In addition, governments may introduce mandatory safety inspections for flying cars, similar to how airplanes undergo regular maintenance checks. 7. Redesigning parking and storage spaces. Unlike regular cars, flying vehicles won't require traditional parking lots. Instead, they will need vertical storage solutions such as hanging docking stations, similar to drone docking bays. These will allow flying cars to be stored in compact spaces. Underground storage. Some companies are experimenting with subterranean hangars for flying vehicles. Foldable wing technology. Some models, like the Klein Vision Air Car, feature retractable wings that allow them to be parked in regular garages. 8. Long-term vision. The creation of sky cities. As flying car technology advances, some futurists predict the development of entire cities designed for aerial transportation. These sky cities would feature floating skyports that connect different districts, self-sustaining energy grids powered by wind and solar, autonomous flying taxis replacing traditional public transport. While this vision is still decades away, the groundwork for aerial urban development is already being laid today. By investing in smart infrastructure, energy-efficient designs, and advanced traffic management systems, cities can seamlessly integrate flying cars into daily life, bringing us closer to a future where urban travel is faster, safer, and more efficient. Artificial intelligence, AI, and automation are at the heart of flying car technology, enabling vehicles to operate safely, efficiently, and with minimal human intervention. Unlike traditional cars, which rely on human drivers, flying cars must navigate three-dimensional airspace, avoid obstacles, and coordinate with other aerial vehicles, all in real time. To make this possible, engineers are developing AI-driven navigation systems, autonomous flight controls, and smart air traffic management platforms that will allow flying cars to function with minimal or no human input. These advancements will make flying cars safer, more accessible, and widely available to the general public. 1. AI-powered autonomous flight systems. One of the biggest challenges of flying cars is ensuring that they can fly safely and efficiently without requiring highly trained pilots. Most people do not have a pilot's license, and training millions of new pilots would take years. This is where AI-driven autopilot technology comes in. Modern flying cars are being designed to operate in a manner similar to autonomous drones, using AI and machine learning algorithms to take off and land autonomously. AI can analyze weather conditions, wind speed, and air traffic before executing a smooth takeoff or landing. Navigate through city airspace. AI can detect and avoid buildings, power lines, birds, and other flying vehicles in real time. Adapt to emergency situations. In the event of an engine failure or power loss, AI can automatically guide the vehicle to the nearest safe landing zone. By removing the need for a human pilot, AI will make flying cars more accessible to everyday commuters, allowing anyone to travel through the skies without specialized training. 2. Smart traffic coordination, preventing mid-air collisions. Unlike traditional roads, where traffic lights and lane markings help control vehicle movement, the skies have no physical boundaries. Without proper coordination, thousands of flying cars in urban areas could lead to chaos, congestion, and mid-air collisions. To prevent this, AI-powered urban air traffic management (UATM) systems will be developed to regulate flying cars just as air traffic control towers manage commercial planes. These AI systems will create invisible flight corridors. AI will divide city airspace into different lanes and altitudes, ensuring that flying cars follow designated routes. Communicate with other vehicles in real time. AI will enable flying cars to send and receive data, helping them avoid collisions. Predict traffic patterns by analyzing weather conditions, rush hour trends, and emergency situations. AI can adjust flight paths dynamically to optimize air traffic flow. Some companies, like NASA and Uber Elevate, are already testing AI-powered air traffic control platforms that could soon regulate urban aerial transportation. 3. AI-enhanced safety systems, reducing the risk of accidents. Safety is one of the biggest concerns surrounding flying cars. Unlike traditional vehicles, a mechanical failure in the air can have far more severe consequences. AI and automation play a crucial role in reducing these risks by constantly monitoring and adjusting flight operations. Key AI-powered safety features include predictive maintenance. AI sensors continuously scan for signs of wear and tear in the vehicle's structure, battery, and propulsion system. If a problem is detected, the system can alert the owner or even ground the vehicle automatically to prevent an accident. Automated collision avoidance. Using LiDAR, radar, and computer vision, AI can detect objects in the air, including buildings, birds, and other flying vehicles, and adjust the flight path accordingly. Emergency response protocols. If a failure occurs mid-flight, AI can deploy emergency parachutes, activate backup propulsion systems, locate the nearest emergency landing site. With these AI-powered safety mechanisms in place, flying cars will be significantly safer than manually operated aircraft, reducing the likelihood of human error. 4. AI-powered navigation, adapting to weather and environmental changes. Weather conditions pose one of the greatest risks to aerial transportation. Unlike ground vehicles, which can operate in rain, snow, or fog with minimal impact, flying cars rely on clear skies and stable atmospheric conditions for safe travel. AI-driven navigation systems will help flying cars adapt to unpredictable weather by analyzing real-time weather data from satellites, radar stations, and meteorological services, adjusting flight altitude and speed to avoid turbulence or strong winds, suggesting alternate routes to bypass dangerous weather conditions. By incorporating AI-powered weather monitoring, flying cars can operate more reliably and safely, even in challenging conditions. 5. AI in air traffic decision-making, preventing congestion and delays. In traditional traffic systems, congestion is a major problem that leads to delays, fuel wastage, and accidents. AI can help eliminate these issues in flying cars by predicting high traffic periods and adjusting flight schedules accordingly. Optimizing flight routes in real time to reduce congestion in busy air corridors. Coordinating with smart city infrastructure, such as AI-powered traffic lights and ride-sharing platforms. This level of AI-driven traffic optimization will ensure that flying cars operate smoothly without causing gridlock in the skies. 6. AI and voice-controlled flight assistance. To make flying cars more user-friendly, AI-powered voice assistants, similar to Siri or Alexa, will allow passengers to control their vehicle through simple voice commands. Instead of manually inputting coordinates or adjusting flight settings, users will be able to say things like, "Take me to the nearest vertiport," "Find the fastest route to downtown," "Check battery levels," and "Schedule a recharge." This hands-free AI assistance will make flying cars as easy to operate as using a smartphone GPS. 7. AI-powered security and cyber threat prevention. As flying cars become more reliant on software, they will also become vulnerable to cyber threats. Hackers could attempt to take control of vehicles, disrupt air traffic systems, or steal passenger data. AI-driven cybersecurity systems will protect against these threats by detecting and blocking unauthorized access attempts, encrypting flight control data to prevent hacking, automatically overriding suspicious commands to maintain passenger safety. By integrating advanced AI cybersecurity measures, flying cars will remain secure and reliable in an increasingly digital world. 8. The future of AI-driven flying car networks. Looking ahead, AI will continue to play a central role in the evolution of flying cars. Future advancements may include fully autonomous aerial highways where flying cars communicate seamlessly with drones, planes, and city infrastructure. AI-powered air taxis that can be hailed instantly through mobile apps, much like ride-sharing services today. Personalized AI co-pilots that learn a user's travel habits and recommend optimized routes and schedules. With these innovations, AI and automation will redefine how humans interact with transportation, making flying cars as common and convenient as traditional vehicles today. As the world shifts towards sustainable transportation, the introduction of flying cars raises important questions about their environmental impact. Traditional air travel has been a major contributor to carbon emissions, and if flying cars were to rely on fossil fuels, they could worsen the problem rather than solve it. However, modern flying car designs are increasingly focused on being eco-friendly, using electric propulsion, renewable energy sources, and noise reduction technologies to minimize their environmental footprint. The goal is to ensure that flying cars don't just revolutionize transportation but also contribute to a cleaner, greener future. 1. The rise of electric flying cars, reducing carbon emissions. Most companies developing flying cars are choosing electric propulsion systems over traditional fuel-powered engines. These electric vertical takeoff and landing (eVTOL) vehicles run on powerful lithium-ion or solid-state batteries, similar to those used in electric cars. Switching to electric flying cars offers several environmental benefits. Zero emissions. Unlike gasoline-powered helicopters and airplanes, electric flying cars produce no carbon dioxide or air pollutants. Lower energy consumption. Electric motors are far more efficient than combustion engines, requiring less energy to operate. Integration with renewable energy. Future charging stations for flying cars could be powered by solar, wind, or hydroelectric energy, making air travel more sustainable. Companies like Joby Aviation, Lilium, and Archer Aviation are leading the development of fully electric flying vehicles, proving that the future of airborne mobility can be clean and green. 2. Reducing noise pollution, a quieter urban sky. One major concern about flying cars is noise pollution. Traditional helicopters and airplanes are extremely loud, which makes them unsuitable for city environments. If thousands of flying cars were operating over urban areas, the noise levels could become unbearable. To solve this issue, engineers are developing low-noise propulsion systems that use electric motors instead of combustion engines, which produce much less noise. Multiple smaller rotors instead of one large one, spreading out the sound and reducing overall noise levels. Advanced aerodynamics, designing flying cars to glide smoothly and quietly. Tests conducted by companies like EHang and Volocopter have shown that modern electric flying cars can be as quiet as normal city traffic, making them far less disruptive than helicopters. 3. Sustainable materials, building greener flying cars. Another key factor in making flying cars eco-friendly is the use of sustainable materials. Traditional aircraft are built from aluminum and carbon fiber composites, which require a lot of energy to produce and are not always recyclable. Innovations in green manufacturing are introducing lightweight biodegradable composites, reducing waste and energy consumption. Recyclable battery materials, ensuring that electric propulsion systems don't contribute to toxic electronic waste. 3D printing technology, which reduces material waste and energy use in the manufacturing process. By focusing on sustainable production methods, flying car companies can ensure that their vehicles have a minimal environmental impact from production to disposal. 4. Reducing urban congestion and energy waste. While ground vehicles experience traffic congestion, flying cars can move directly from point A to point B, reducing the overall energy wasted in stop-and-go traffic. Studies suggest that flying cars could reduce travel distances by 40 to 60%, cutting overall energy consumption. Improve fuel efficiency by eliminating unnecessary stops and idling. Lower demand for highways and roads, allowing cities to convert more land into green spaces rather than expanding road networks. If properly integrated into urban infrastructure, flying cars could actually help reduce pollution by lowering dependence on gas-powered vehicles. 5. Challenges of battery waste and recycling. One major sustainability challenge for electric flying cars is the life cycle of their batteries. While electric propulsion eliminates emissions, lithium-ion batteries have a limited lifespan, and improper disposal can lead to toxic waste and environmental damage. To address this, companies are working on battery recycling programs, repurposing old batteries for secondary use. Solid-state battery technology, which lasts longer and produces less waste than lithium-ion batteries. Wireless and renewable energy charging systems, reducing battery wear and tear. By ensuring responsible battery disposal and recycling, the flying car industry can prevent environmental damage and make electric aviation truly sustainable. 6. Integration with renewable energy grids. For flying cars to be 100% green, they must be powered by clean energy sources rather than electricity generated from fossil fuels. Cities are now exploring ways to integrate flying car charging stations with renewable energy grids, such as solar-powered vertiports, using rooftop solar panels to generate electricity for flying car charging. Wind-powered charging hubs, utilizing offshore wind farms to supply energy. Hydrogen fuel cells, an alternative to batteries that produces zero emissions and can be recharged faster. Countries like Norway, Germany, and Japan are already investing in renewable power transportation networks, and flying cars could be a natural extension of this movement. 7. Regulating the environmental impact of flying cars. Governments and environmental agencies are closely monitoring the development of flying cars to ensure they meet strict sustainability standards. Potential regulations could include carbon footprint limits, requiring flying car manufacturers to offset emissions. Energy efficiency standards, mandating the use of eco-friendly batteries and motors. Flight restrictions in protected areas, ensuring that flying cars don't disrupt wildlife or natural ecosystems. Some cities, such as Singapore and Los Angeles, are already planning eco-friendly flying car policies to make sure this technology benefits both people and the planet. 8. The future of green aviation, a carbon-free sky. Looking ahead, the flying car industry is on track to become a leader in green aviation. In the next few decades, we may see self-sustaining aerial transportation systems, where all flights are powered by renewable energy. Hyper-efficient air traffic networks, minimizing energy waste and optimizing flight efficiency. Global initiatives to eliminate carbon emissions from aviation, making flying cars a cornerstone of the fight against climate change. By focusing on sustainability, energy efficiency, and responsible manufacturing, flying cars can usher in a new era of eco-friendly transportation that benefits both urban mobility and the environment.